I'm going to focus in on two of the main layers. There's several others, but we're going to spend our time talking about uh, two of the main layers. First off, the stratum bacilli. This is the base layer, which is exactly what stratum bacilli translates to. This is the layer that lies next to the dermis. Cells here continually divide. This is where mitosis is going to occur. This is where new cells are formed and will move up through those layers that we've identified, like that conveyor belt that we've talked about. Stratum bacilli is a single layer of cells. There's only one layer of cells that are going to go through cell division, and each time they go through cell division, the new cell gets kind of pushed up a layer, and so on until they're the layer of cells that are going to be sloughed off. The other thing we're going to talk about are the stratum corneum. These are the uppermost layers. So what we're kind of talking about is the bottom, the deepest layers, and the most superficial layers. These make up about 25 or more layers of what I refer to as shingle-like cells. These cells are dead. They're shingle-like so that they can provide the protection like the shingles of a roof do for your home. They act as overlapping layers to keep what should be outside and what should be inside on the inside. Keratin fibers are present to give structural strength. These keratin fibers are those protein fibers that we talked in our last lecture about that are formed through the process of keratinization. That's the last thing we spoke of with our last lecture. These are the fibers that allow your epidermis to have the characteristics, the functional characteristics that it does in fact have. Here we're going to have those flaky looking cells that we identified that are going to desquamate or slough off to help protect the deeper layers from abrasion. This is a really good photograph. It's a close-up of just the epidermis. If we look at the lower cells, they look cell-like. They look maybe a little bit smaller because that's where we're going to see cell division occurring. And they look cell-like. And as we move up to the mid-range, they look really very much like those squamous epithelial cells that we've seen in lab. Very clear nuclei. They're very cellular looking, if you will. As we move up towards the top of that photograph, we see fewer and fewer nuclei because they're being broken down. The cells being taken over by those keratin fibers. The cells are looking less cell-like and flattening out on us and becoming shingle-like. Way up at the top, you see those kind of flaky cells that we saw before. Those are the ones that are going to slough off. Now, when we talk about our skin, probably the most well-known, if you will, pathology or disease associated with it is skin cancer. There are 3 different types of skin cancers that we can identify. We'll start with the basal cell carcinoma. This is the most common variety of skin cancer that we've identified. And if we look at the name, it will not surprise us to know that it's going to start in the stratum bacilli, in that base layer, that mitotic layer. These tumors invade the dermis and the hypodermis, which means they're going to grow deep into your body. Not deep into the layers of the skin, not deep into your body per se, but going deep, going down into the lower layers of the skin. The good news about basal cell carcinoma is it has little chance of metastasizing. Let's take a step back for a second and figure out what metastasizing means. Very simply, it is the ability of a cancer to spread. When we say a cancer has metastasized, it's spread from its original location to another location in your body. For example, let's say you had a basal cell carcinoma. If that cancer metastasized, and again, it's unlikely, but let's, for our sake of argument, it metastasized and it went to your lungs. That doesn't mean you now have lung cancer. What that means is you have a basal cell carcinoma that has metastasized or spread to your lungs. It's gone to another location. As I say, the good news about basal cell carcinoma, it has a very little chance of metastasizing, so it's a fairly easy cancer to cure. Right? We typically have a very, very good chance of a full cure. What happens is a dermatologist or a surgeon, depending on the size of the tumor, will excise the tumor, remove it surgically. What you see here are two photographs of basal cell carcinoma. Because they're so close up, they look really kind of big, but if you compare them with reference to the size of the hair surrounding them, you see that they're really relatively small and easy to remove when when we look at it in reference to other cancers that are much more invasive and can do much more damage. Our second type of skin cancer is a squamous cell carcinoma. These arise in the stratum spinosum, which is a layer of the epidermis that's located between the stratum basal that we talked about and the stratum corneum. The tumor is confined to the epidermis. It doesn't grow down, doesn't grow deep into the layers of the skin. It just kind of stays right, very superficial to the surface of the skin. Bad news about squamous cell carcinoma, it's a bit more serious than the basal. It can metastasize to the lymph nodes. Metastasizing to the lymph nodes can allow any cancer, specifically the squamous cell carcinoma, to spread throughout the body. However, if it's caught early, again, there's a good survival rate. These are two photographs of squamous cell carcinoma tumors, and again, they're larger than the basal cell were, but if you compare to the size of the hairs around them, you see that they're not too terribly large. But again, any cancer is very serious and we want to get them removed as soon as possible. The third and most scary, if you will, type of cancer is malignant melanoma. It's scary because it's the most deadly of the skin cancers. In years past, I would say in this lecture that there was about a 1% survival rate. That has changed drastically over the last, 15, 20 years. The survival rate is much, much better. Malignant melanoma, as you may have been able to guess, is a cancer of the melanocytes, those cells in the epidermis that are going to produce melanin. Metastasizes quickly to the lymph and blood vessels. This is very, very dangerous because the faster it metastasizes, that means the faster it spreads throughout your body. They are flat, spreading lesions. They are typically pigmented. They have color to them, whereas the others didn't. They were kind of skin tone. A melanoma is going to be pigmented because it is a cancer of those cells that produce the pigment. Typically, we use the ABCD rule to detect whether or not a cancer is a malignant melanoma. We'll talk about what that means in a moment. Here are two photographs of malignant melanoma, and please note a couple of characteristics about these growths. The edges are not smooth, they're kind of a wavy, scalloped edge. The color is not consistent across the growth. This is going to be important for us when we go through our ABCD rule. All right, so ABCD rule. A is asymmetry. If something is symmetrical, that means it matches. Both sides are the same. We say the human body has something called bilateral symmetry. What you have on one side of your body, you have on the other side. You have a left arm, you have a right arm. You have a left leg, you have a right leg. When something is asymmetrical, the sides do not match. And that's important when we look at a pigmented mole. If the two sides don't match, that is a cause for concern, as we saw in the photograph just previous. B is for border irregularity. Again, as we saw in the photograph previous, the borders of the mole are not smooth. They have a scalloped edge, they have a rough edge to them. C, color. Different colors in the pigmented area. If you look at a regular old freckle, typically the color is the same throughout that freckle. In a malignant melanoma, as you saw, the color can be patchy, the color can be different throughout that growth. And D is diameter. The spot is larger than 6 millimeters in diameter. This has kind of changed a bit over the years. We've come to realize that, again, with any cancer, early detection is the best. So by the time something has grown 6 millimeters, and that's about the diameter of a pencil eraser, it's really quite large for malignant melanoma. So the sooner we get at that, the better it's going to be. Now, if we look at these four photographs, the upper left is illustrating it being asymmetrical, that both sides of the mold don't match. Upper right, the border is irregular, it's not smooth. Lower left, is the color is not consistent, and lower right is talking about the size issue. But again, with size, we want to get that looked at as soon as possible because the smaller it is, the better the cure rate is going to be. This is a neat diagram. I think I found it on the internet. It shows you on the left normal epidermis, right? The different cells, how they're going to look. To the right, it shows you the 3 different types of skin cancer and where they're going to be placed in the layers of the skin. If you look in the middle, the basal cell carcinoma we said was going to grow deep, go down towards the dermis and the hypodermis, and that's exactly what it's doing. We look at the left, the squamous cell, it's really stayed in that epidermal layer, hasn't gone too crazy far down. And the melanoma, as you see, is spreading and quite large. Glands, as we say, are derivatives of the integumentary system. They're parts of the skin. Specifically, we'll talk about our sebaceous glands. We talked about our sebaceous glands when we talked about how our glands function for our first exam. Sebaceous glands are located in the dermis. They produce an oily white substance, that sebum we talked about. The function of that sebum is to moisturize your hair and skin, to act as a natural moisturizer to keep your skin in good working order. Sebaceous glands produce sebum as a holocrine gland will. If you don't remember what a holocrine gland is, you're going to want to refer back to your Exam 1 packet so that you can remember how holocrine glands form their product. The duct of a sebaceous gland is going to open into the upper portion of a hair follicle. I've got a diagram for you in a moment. And as we say, the sebum is necessary to moisturize your hair and skin and keep your skin in good working order. Here's a diagram. We have a hair follicle growing there, and you see the sebaceous gland has a duct that's going to connect it to the hair follicle and cause the sebum to be pumped up through that hair follicle out onto the surface of the epidermis. There are 2 types of sweat glands that we can identify. First is a merocrine gland, and again, we're going to identify these glands by how they're functioning, so you want to be aware of that and get out that Lecture 1 packet. For a merocrine gland, the duct opens to the skin surface. It produces sweat. It's going to be a hypotonic solution of sodium chloride, urea, ammonia, uric acid, and lactic acid. These are all things that are going to be produced through exercise when your body's trying to cool itself. Merocrine glands are located in the palms of the hands, soles of the feet, and axillae. Axillae is a really fancy word that simply means in your armpits. So when you think about when you're working out, when you're warm, where are you sweating? Typically your armpits, palms of your hands, soles of your feet. Those are going to be these merocrine glands, and they're just producing this regular kind of sweat that we produce when we work out. Next, we have apocrine glands. This duct opens to the hair follicle. The glands themselves extend down into the hypodermis. They secrete quickly metabolized organic substances. The problem with that is the result of this is body odor. So that body funk that some folks have that you smell sometimes when you're in a group is caused by these apocrine glands. They're located in the axilla, the genitalia, and around the anus. Here we have our 2 different types of glands. The apocrine gland is to the right, and the ecrine is the same as the merocrine gland that I spoke of, right? Ecrine, merocrine, potato, potato. And you'll see that the ecrine or merocrine gland, the duct dumps right out onto the skin, whereas the apocrine, the duct fuses or merges with a hair follicle, and that's what will cause what we refer to as that body funk. This brings us to the end of our integumentary system, so we'll end this lecture and we'll start up with our next lecture with our skeletal system. Thank you.